Hello student, I am Arnab Das. Today we discuss about the convolution code with another kind of example. Consider a 322 encoder. Obtain the encoded sequence for the input U1 is 10 and U2 is 11. So from this information we can able to identify that there the convolution code, the number of input will be defined by the 2. Why? Because here it is given that 3 comma 2 comma of 2, that means 3 is indicate for the value of n, number of output terminal will be defined, and k is defined how many number of input is there, and that is the 2 in this case, and m is defined how many number of memory unit you have to use on that to encode the message. So here 3 is the output line, 2 is the input line, and 2 is memory unit. From the figure also you can able to identify that there three outputs are defined as a V1, V2 and the V3, and two inputs are provided as a form of the U1 and U2. Their maximum number of memory unit you have to record for getting the output is 2 on there for the V3. Look that there to get the V3 this two memory unit should have to record. For another cases, let for the V1, there no memory unit you have to record. For the V2 also, there no memory you have to record. But for the V3, there for the minimum path, there the number of input you have to record. This is 2. So it is defined as a 3, 2, 2 types of convolution code encoder. Now the question is that for the input U1 is specified as a 10 and the U2 is the 11, what will be the encoded sequence? So initially at first you have to identify for the V1 what will be the expression form. V1 is equal to, if you consider P1, P2, P3 the state position, look that here P1 is defined the instantaneous value, P2 is the after the M1, that is the previous value of M1 is defined by the P2, and if we consider there another kind of memory unit is present and let this is the M2, their previous output will be as a P3. Same way for this line, their P1 dash is defined the instantaneous value for the U2, P2 dash is defined the previous value of M3 memory unit, and P3 dash is the previous value for the memory unit M4. So if you want to get the value of U1 only for the U1, that is initially we just apply the condition that U1 is applied, and that time U1 is not connected from. And when you consider this one is active, that is the U2 is active, that time you have to consider that U1 is inactive or no input is provided on there. If the individual effect is known by you, then by adding these two will be defined the ultimate output due to the region of U1, U2. That means you are applying in here the superposition theorem form. That is the individual effect will be defined as the total effect of the total input one sequence. So initially we just consider for the U1, you are considering only the U1 as the input, but U2 is on that case obsolete. So if for the U1 is applied, that time V1 the expression will be V1, it is directly depend on the P1. So remaining P2 and P3 is not connected or the addition is not occurred to get the output of v1. So this the sequence will be represented as a form of 1 0 0. Same way for the u1, if you consider the output v2, that time here it is depend on the p1 dash, and that is inactive. So here each and every one element, that is the p1 p2 p3, not connected here to get the result v of 2. So each and every element for the p1 p2 p3 will be 0 on here. Now for the v3, when only u1 is applying as input, so what happened, v3 is, look that here p2 is only used on there, this one is only used on there to get the result of v3. So remaining two, that is the p1 and p2, you should have to apply as a 0. So combination will be as a form of 0 1 0 on there only for the input of u1 to get the output v3. Now you consider for the u2, that means when you applying the u2 only and u1 is inactive form, that is no input is applying for the u1, what happened on there? So to get the v1, that time p1 dash, p2 dash and p3 dash, no one is used on there. So each and every element, in this case it will be 0. Now for the v3, what will be, sorry, for the v2, what will be, for the v2 it is directly connect with the p1 dash, the remaining p2 dash and p3 dash is not used on there, so it will be 1 0 0 on there. What will be the for the v3? So for the v3, look that here p2 is used, p2 dash, p3 dash also is used on here. So what will be the form? p1 dash is not used, so this will be 0 1 1. So due to the reason of u2, only for the reason of the u2, v3 will be defined as a 0 1 1. So this is the ultimate notation by which you can so easily able to get the output form. Now we are checking the table. So in this case, if you consider the u1, look that here u1 input is provided as the 1 0. So first you have to apply the 1 and then 0, and extra 2-bit data you have to apply as the input of 0, because memory unit is there 2. So the table also provided you as such, that is this is defined 1 0 and extra 2-bit is used on there due to the reason of memory unit is there 2. So this is 1 0 0 input combination. What will be the m1 m2? Look that for the m1 you already decide, this is due to the reason of instantaneous value of the input. For the figure, if you check on there, for the m1 there, for the m1 there, this is due to the reason of instantaneous value, that is input will become as the reflect of m1. Okay, and m2 is will be the previous value of m1. So you can check this one in here. So this instantaneous value of input 1 is come in this position for the m1, and previous value of m1 is come as the m2. If you check for this line, for this line input is a 0, so come there 0, and previous value is 0 for the m1, and so output will be for the m2 or stored will be 0. So in this way you can do that table. So this m1 m2 side you can able to identify. Now you have to check v1 v2 v3. So first one is the v1, this is for v1 column, this is v2 column, and this one is the v3 column. So v1 is defined as a form of, check that, v1 is the form of 1 and another are as a 0, so this is not effect on there. You just put the value of the instantaneous value of the present input. So look that here the 1 is come in this position, there the 0, so this is reflect 0. In such way the input which is provided, that one is reflected at the v1 position. And you also check that for the v2, only for the u2, v2 will be each and every one element are 0. Look that each and every element are there 0. So there any kind of combination of input, that the output maintain always as a 0. So it is always maintain as a value of 0. Whatever of input you are applying, though the v2 should be maintained as a 0. Now for the v3, look that this is only depend on the p2. This is only depend on the p2. That means the previous value of m1. So m1 previous value will become as a v3 output. So look that m1 previous value is in this case 0. So it is come in this position. Now if you consider for this line, previous value for the m1 is 0, so it is put at the 0. If you consider in this line, that time previous value is 0, so it is put it as 0. This if you consider this one line, previous value is the 1, so it is put the value of 1. In this way you can build the table which one is the reason for the only of u1. So this is the complete table for the u1. Now the same way, if you consider only for the u2 equation, already know that this one is given that if you consider for the only for the u2, that time v1 is always maintained as a 0, v2 is the instantaneous value. Look that v1 is always maintained 0 and v2 is the instantaneous value of input, so this is 1100 is applied, and v3 is defined the previous value of m3 and m4. So if you consider this one line, so here the previous value was 10, so look that 10 odd operation will be, or mod 2 addition will be 1 plus 0 will be 1, so it is as a form of 1. If you consider for this line, so previous value both are the as 1, so 1 plus 1 as a mod 2 addition, the result will be 0, so this is 0. So in this way you can got the individual input value, what will be the output one. Now if you add between them, that is the mod 2 addition, if you do here, you can got it this one due to the reason of u1, the output is defined as a 100, then 001. Check that this is 100, then 001, then 000, then again 000. So in here also it is defined as such. This is 100, 001, 000. Same way for the u2, the output vector will be defined as a 010, 011, 000, 0001. If you mod 2 addition you done that time, between these two the mod 2 addition will be 110. For this it will be 001 and 011, the result will be 010. If you consider, I think it will be little bit curious for you, that because if you add between them 1 1, then the carry will be generated. Why not it will become as addition? No, we are considering only the single bit result one form. So for the single bit 1 and 1, the result will be 0. For the single bit 0 and 1, it will be 1 in this way. It is written as a 0, 1, 0. Same way for the condition of 0, 0, 0 and 0, 0, 0, the result will be triple 0. In this case, this will be 0, 0, 1. So ultimately, we can able to identify that the value is, that is the total for these two input, the total value will be defined as, for the encoded value will be defined as 1 1 0 0 1 0 triple 0 and 0 0 1. Although methods seem to be simple, it is not feasible for the large value of m, k and n. That means in this case we just considered the 221 or 322. So this is so simple one. Message bit is there or line is there 2 or 3 as such. But if the memory unit is much larger and k and n, that is the input line and output line also the much high, then obviously what happened? This kind of formation will be so complicated for you. So this is not a easy way for getting the convolution code, and for this reason there another kind of process you can be applied, that is the convolution encoding. And what would be done on there? The convolution code can be viewed as a LTI system whose output can be obtained by just convoluting the input sequence with the impulse response of the system. The impulse response of the convolution encoder, which is also called the generator sequence, can be obtained by giving an impulse function 1000 as an input. For the 212 encoder, the previous first example I just explained, the impulse response of the generator sequence can be obtained as a g1 is equal to 111. This is the 101. This is done by using the p1 p2 p3, whatever you have to got it on there. As you say, for this case, for this today example, this is defined the g1. Look that this is the defined the g1. G1 is, as you say, for the u1, this is defined the 100. For the g2 is defined the 00, and for the g3 is defined the 010. Same way for the input u2, the g12 will be defined as a 000 then g2 will be defined the 100, and g3 will be defined as a 011. So the way by which what kind of input is applying on that point of view, you can able to generate this g1 g2. If you know these two, then you just convolute between g1 the input sequence. Let the input is applying as a 11101, so you just convolute g1 with u and g2 also you convolute. What is the convolution process? You just apply column with the g1. Look that g1 in this case 111, so column is there 111 on there, and the input is provided as a 110, so that one is written in this case. The convolution by using this is the 1 is multiplied with the 1, so this is 1, and this total 1 is reflected in this position. Total 1 is reflected in this position. Again this one also reflect in this position, because multiply 1 with the this total 1, so this will reflect on here. Now by the diagonal process you have to mod by addition you have to do. So this will be 1. Now this is 1 plus of 1, it is 0. Triple 1, that means it will be 1. Again this is 011, so it will be 0. Then this is 101, so it will be again 0. Then this is 10, so this is 1. Look that this is 1. Lastly 1, so this is 1. So for the v1 will be defined this one, and same process you just apply for the another g2, that is the 1 0 0. So when this is 1, that time it will be reflect in this position. For the 0, all value will be 0. 1, it will be again reflect on this, and then row wise, sorry, diagonal wise, you just mod 2 addition process you do on there. So it will be 1, it will be as a value of um, 1. Look, that this is 1 1 0, so this is 1, this is 1 0 1, that means 1 plus 0 plus 1, that is 0. Now this is 0 0 1, so this is 1 1 0 1, it will be 0 0 0 is 0, then 1 is 1. So what will be the sequence? We just now one after even you just write down. So encoded output will be 1, and this is 1. Encoded output will be defined as the 1, this is 1, so write down 1 1 first, then this is 0, then 1, so this is 0 1, this is 1, again this is 0, so this is 1 0. In this way you can do the output sequence. So this is the process by which convolution code can be done on there. So for the second example here, suffix is defined for the output, and the input is provided by the 1. So individual 1, you have to do the convolution process, because 2 input is present, so you have to two kind of convolution you have to add in here. Again, I just repeat that addition means the mod 2 addition you are doing on here. So for the v1 you got it on there, the value of 1 triple 0. For the v2, so the same way the value will become on there as a 1100. And for the v3, because three input outputs are there, v3 by using the same way, like again just repeat that this is the g3 is define the output terminal line for the generator, and 1 is the input for the one, and that means superscript is defined for the input for which input you are considering, and g3 is the for which output line you are choosing. Then you have to do the convolution process. So for the u1 is the 1 0, and u2 is both are the 1 1, so this is 1 1, and this is for the 1 0, and g3 1 is this one is the 0 1 0, this is 0 1 1. Then if you do this one, so the process can become as such, and the ultimate v3 will become this one value. Now you just write down this one as I told previously, so that time the output sequence can be write down as such, that is the output encoded data for that particular message will be as such, and which will be the same which is already calculated by previous form. So I think each and everyone can able to understand by which we can identify the what will be the encoded data by generalized process, and also by the convolution way for the convolution code. So next day we meet again with the new process or new way for the convolution code, and till have a good day and stay safe.